Okay, for this next type of problem, we're going to move into log equations, and this is the third type of equation that you could see. So here we're going to be dealing with log equations that have the same base. Now this is going to require us to review some principles from earlier, but it's very similar to what we dealt with exponential equations that had the same base. The bases just more or less cancel each other out, and so we can see here in this particular statement that if they both have the same log value, then the units can equal to each other. Now let's take a look at why that works here just briefly. If you recall from previous lessons, and we could basically say that the log base b of b to the x power, that this was all going to cancel out, and so this was just simply going to be left with the value of x, which was the exponent. Well, we have a similar situation here where if I had an exponent, I had a base for an exponent, but the exponent itself was equal to a log, then what happens is this base and this log base also more or less cancel each other out, leaving us just simply the x value. And I know that looks a little confusing, but you can see here, you know, this is a base of a base, and if we rewrote this as a log value, you could see how that would cancel out. So this is kind of confusing, but let's see how it plays out a little bit if we're dealing with logs of the same base. So let's say, for instance, we have log base 2 of x equals log base 2 of 4. Well, in previous lessons, we've taught you to rewrite logs as an exponent, and I know this would seem kind of silly to do at this point, but we could actually take this base of 2, raise it to the log base 2 4, and of course that's going to simply equal to x. Now, if we use what we've learned up here, we know that if the log base and the exponent base are the same, they more or less just cancel out, and that's basically what we've got here, leaving us equaling just the 4, and so we get 4 equals to x. Well, that being the case, we can skip all this middle part, and if we recognize that the logs have equal bases, that we could simply tell that x is going to equal to 4 as opposed to having to go through this property. But this property is the reason why it works. Well, knowing why it works is one thing, but knowing how to get to the final answer is another, and getting to the final answer here is a heck of a lot easier than having to take all those properties into account. So if we look at example problem number 3, using this property makes life a lot easier, because you can see we have log base 3 and log base 3, excuse me, it disappeared on me, and since that's the case, they don't technically cancel out, but I'm going to make it look that way. And what's going to happen is that's going to give us 5x minus 1 by itself and x plus 7 by itself. And now we have a simple algebra 1 equation that we can solve for x. And so we want to take advantage of understanding the property but not having to write out all the steps. So in sample problem number 4, we just want you to solve this log equation with the bases being the same. So go ahead and try that now. Okay, so this ought to be pretty straightforward and simple at this point. We see log base 4, log base 4. So we can say that x plus 3 is equal to 8x plus 17 without having to go through all of the rewriting steps that are necessary. And now we're simply into an algebra equation that we can solve for x. So I'm going to subtract x from both sides. That gives me 7x there. I'm going to subtract 17 from both sides, which gives me negative 14 on this side. And then after I divide 7 from both sides, I get x is equal to negative 2. Alright, that gives us our third example Now we're dealing with log equations instead of exponential equations. Similar principles though.